Hello students, welcome to KENE'S Educare, a group of KENE solutions. This is part 5 of lesson number 9, Force and Laws of Motion. So as you all remember, in part 4 we started with the discussion on we started discussing about the second law of motion, right? And there's a statement that I told that every one of you should be remembering, and that statement is that of the second, what does exactly the second law of motion states, right? Then after that, today we are going to discuss on mathematical derivation for coming up with you can say with the second law, because in second law we had about momentum, right? And we know that momentum is equal to, like, we represent momentum with the letter P, right? So momentum P is equal to mass of is equal to product of mass into velocity, that is mv, right? So we will be mathematically deriving it today. But before that, I want each one of you to please revise each and everything that we discussed in the last class, that is the second law of motion. As well as before that, we even started our discussion, like we have discussed on first law of motion as well, which we also know it as law of inertia. Okay, and there were many different examples which were given, and which we even discussed on when it comes to first law. And even for second law, if you have seen, like we have 5 to 6 examples how to calculate it. We will be like going through all of them, and different examples are again given, so we'll go through them all. Okay, so now I want you all to please go through whatever we have discussed, or whatever notes you have taken off from part 1, because part 1 was the introductory part, so you have all the basic things in that, right? So please go through it, everyone. I hope every one of you have started revising it. I hope every one of you are revising it. So we have started this lesson force and laws of motion by discussing on the basic information which is given on force. So here we have the definition of force that we had discussed, that is it is push or pull on an object that produces acceleration in the body on which it acts. And if you remember in part 1, while introducing the lesson, I made you all write the definition of push and pull as well, along with few examples, right? So I hope every one of you have revised it as well. So I hope you all are going through it, because here we have more information on it, like what force exactly can do on a body. So we know that force can change the speed of a body, it can change the direction of the motion of the body, and it can even change the shape of the body, right? So these are the things that force can do on a body. So I just want you all to please go through it. I hope every one of you are going through this slide. Then we discussed on effects of force, like it can be understood by the following point, and you can see the picture as well, so please revise it as well. So then after that we discussed on that forces can be of two types. One, first is the balanced force, and after that we have the unbalanced force. So over here we have the information on balanced force which has been given. I want each one of you to please go through it quickly. So sorry. I hope everyone has gone through the balanced force, and the picture clearly explains you about the balanced force. And if you remember, the example that I gave you was with respect to tug of war, right? Then we discussed on unbalanced force, and here we have more explanation along with you can say an example that has been clearly explained in the picture as well, right? So please go through this, everyone, and then we'll proceed further. I hope you all are revising it because revision is very important. Otherwise, you will get confused with the topics as well, and you won't be able to write it in your own words as well. So make sure you're revising it very well. Then we discussed on the first law of motion. So I just want you all to please go through it, and please don't forget that first law of motion is also called as law of inertia. Okay? Then here we have more information about the inclination that has been shown in figure 9.5. Okay, it's just a brief description of it, so please go through it as well, everyone. I hope every one of you are going through it. After this, we discussed about Newton, like as Galileo has some, you can say, Galileo like was arguing about some of the inclination that was there because of the frictionless plane, right? So Newton further studied about Galileo and he came up with three fundamental laws that we are studying now. Okay, so on this slide we have the first law of motion that has been stated, and we state that as an object remains in state of rest or uniform motion in a straight line unless compelled to change that state by an applied force. So in short, like if you haven't got it, in other words we can say all objects resist the change in their state of motion. Okay, so if an external force has been applied, the object at rest is going to move, right? So that is what the first law states, and we also know this first law of motion as inertia. I hope every one of you are going through this slide, because after that we have a short discussion on inertia and mass that we will be doing with the same example of the seat belt which has been explained over here. So make sure you know this slide properly. After this, here we have more information about inertia. So I just want each one of you to please go through it as well. Then we discussed on this activity 9.1. So we had like altogether three different activities, right? So I want you all to please go through it as well. I hope you all are going through the activity and you understand it very well. Then we discussed on like inertia and mass through the example of the seat belt. So I want you all to please go through it as well. Then we started discussing about the second law of motion. So I just want each one of you to please go through the slide as well. I hope every one of you are going through the slide. Then here we have more information about momentum, and the last statement, as you can see, it has like the second law of motion states that the rate of change of momentum of an object is proportional to the applied unbalanced force in the direction of the force, right? I hope you all are going through it. After this, now we will be discussing on the mathematical formulation of the second law of motion. What do you all think? How are we going to do it? Like the mathematical formulation, how exactly it's going to work? See, suppose an object of mass m is moving along a straight line with an initial velocity u. So the mass of the object is represented as m, the initial velocity as u. Okay, now it is uniformly accelerated to velocity v in time t by the application of a constant force f throughout the time t. So here like they have just given that velocity is v, time is t, and the constant force is denoted by f. Okay, so the initial and final momentum of the object over here becomes like p1 will be equal to mu and p2 will be equal to mv respectively. What it will become equal to, p1 will be equal to mu, p2 will be equal to mv respectively. Okay, so the change in momentum, now we know that second law states that change in momentum is directly proportional to p2 minus p1, right? So after that, we know that change in momentum is directly proportional to p2 minus p1. We know p is equal to mv, right? Mass into velocity. So p2 becomes mv and p1 becomes mu. V is the velocity, u is the initial velocity. So m will become common over here and we will have multiplication, that is mass into v minus u. V is velocity, like final velocity minus initial velocity. And now because we have time over here, we need to calculate the rate of change of momentum as well. It becomes equal to, rate of change of momentum is equal to m into v minus u upon t. What it is equal to, m into v minus u upon t. Okay, or when we apply the, like when we have the applied force, we know applied force is denoted as f, then that f, like force, will be directly proportional to m into v minus u upon 2, the same thing. It's just that we know that f is equal to, we have added k is the constant of proportionality, so km into v minus u upon 2. Okay, and we know that v minus u is acceleration, initial velocity minus final velocity, so it's equal to kma. This is what we have, f is equal to kma. Okay, k is constant of proportionality, m is mass, a is acceleration. So here a is equal to v minus u upon t is the acceleration, which is the rate of change of velocity, Okay, so the quantity K is a constant of proportionality where the SI unit of mass and acceleration are kg and meter per second square respectively. What is the SI unit of mass and acceleration? It's kg and meter per second square respectively. For mass it's going to be kg, and for acceleration it's meter per second square. So the unit of force is so chosen that the value of constant k becomes 1. Now we have to choose the unit of force as such that the value of the constant should be 1. So for this, 1 unit of force is defined as, now this is an important definition. What are they defining it as? 1 unit of force is defined as amount that produces an acceleration of 1 meter per second square in an object of 1 kg mass. That is, 1 unit of force will be equal to k is like constant of proportionality, k into 1 kg into 1 meter per second square. Okay, and thus the value of k over here becomes equal to, like becomes 1, and from that equation we get the formula as F is equal to ma, that is mass into acceleration. And we know that the unit of force is kg meter per second square, or we can simply represent it as Newton, that is N, which has the symbol N, capital N. Okay, so the second law of motion gives us a method to measure the force acting on an object as a product of its mass into acceleration. So the second law of motion that we have, that is the product of mass and acceleration, and second law of motion helps us in that. Okay, so the second law of motion is often seen in action in our everyday life. Or have you noticed that while catching a fast moving cricket ball, a fielder in the ground gradually pulls his hand backward with the moving ball? Have you seen, like the fielders who are there like in the ground, they have been scattered, right? So the fielder is going to catch, like gradually pull his hand backward while he has to like catch that, right? So in doing so, the fielder increases the time during which the high velocity of the moving ball decreases to 0. What does the fielder does? The fielder is going to increase the time so that the high velocity of the moving ball should decrease to 0, and like the fielder can catch it easily. And thus the acceleration of the ball is decreased, and therefore the impact of catching the fast moving ball is also reduced. So we are reducing the impact of catching the fast moving ball, and even the acceleration of the ball has been reduced. Okay, so now I want you all to write this thing in your book because it's very important again. I want each one of you to please read it quickly. I hope every one of you are writing it. You have to write over here like how the acceleration and the impact of catching gets impacted because of the second law. So please do mention that as well. So see what happens. While the fielder was catching the ball, if the ball is stopped suddenly, then its high velocity will decrease to zero in a very short interval of time, right? And that is because of the change of momentum of the ball will be very large over here. So because the rate of change of momentum is large, the velocity decreases to zero and the ball stops suddenly. So therefore, a large force would have to be applied for holding the catch that may hurt the palm of the fielders, and that is the reason you know that they wear like so many things, like they cover their body, right? So in a high jump athletic event, the athletes are made to fall either on a cushioned bed or a sand bed. Why is it so? Because to increase the time of the athlete's fall to stop after making the jump, because they need to stop, right? And here what will happen, because when they jump off and they need to stop again there, right? So this will decrease the rate of momentum and hence the force as well. Now what you can do is, if you're not understanding it properly from over here, try to ponder how a karate player breaks a slabs of ice with a single blow. Okay, so in that case, the first law of motion we can mathematically state from the mathematical expression, that is force is equal to mass into acceleration, and we represent that as F is equal to ma. Now we already know A is V minus U upon T, right? Acceleration is V minus U upon T. So here Ft is equal to mv minus mu. So that is, when f is equal to 0, v is equal to u for whatever time t is taken, the object will continue moving with uniform velocity u throughout the time t. Okay, what will happen? The object will continue moving with uniform velocity u throughout the time t, and if u is 0, v will be 0. If the initial velocity is 0, the final velocity will be 0. Okay, and that time when the velocities are 0, the object will remain at rest. What will happen? The object will remain at rest in that case. So now we have the examples to discuss, which I'm going to start with in the next class. That is in the next part. So we have total 5 to 6 examples, which I will try to cover in the next part itself, so that in the next part we can start with third law of motion. Okay, so I'll just show you the examples. Like the examples are like letting us, they are going to help us to, you can say, to calculate or to find out different velocities and all. So I just want you all to have a glance through it. Then we have this third law of motion, which we will discuss on. And again, we have many activities and examples which we will be doing on. Then we have conservation of momentum to discuss. We'll be doing that as well. Okay, then we have the summary discussion that we will be doing. And after the summary, we have like few exercise questions to discuss. So I'm going to show you the questions one by one, and I want each one of you to please go through it properly. I hope everyone is going through the question that I'm showing you on screen, because we will be discussing them once we like complete with the whole lesson, force and laws of motion. So this is how we will be ending up with the whole lesson, force and laws of motion. And I hope each one of you have understood like whatever we discussed with respect to the second law of motion. You are very much clear with it, like how we can mathematically derive like the formula for it, right? So now before I proceed with the next part, for the next part of the lesson, make sure you revise everything so that you understand the further examples as well properly. Okay, so I'll end up with the lesson over here. Thank you everyone.